In previous videos, we went through, or I should say the one previous to this one, we went through and drew our angles in the first quadrant and then determine what sine and cosine were as a result of that. We're going to do the same here, but we're actually going to work in all three quadrants instead of just the first. So our first example, it says, all right, draw a 135-degree angle in standard position on the unit circle. Draw the reference triangle and then determine the sine and the cosine of 135 degrees. Okay, so to get started then 135 degrees, so I know then the first quadrant, that's 90 degrees, another 45, so I've got to draw my angle like this, and this here is my angle, and that's 135 degrees. In order for me to then determine the sine and the cosine, I've got to figure out what this location is, what this point is. So that means then I have to, draw my right triangle, and this would be my reference triangle. So to determine this point, I draw straight down. That means this angle is 45 degrees. That's my reference angle. Well, let's see. I know that based off the other values that we had, if this is 45 degrees, this one's 45 degrees. This length is 1. And then from the work that we did with the 45, 45, 90 right triangle, we know that this side is square root of 2 divided by 2, and this side is square root of 2 divided by 2. That's the side length of the triangle. Now the thing is, though, if I look at my x value is going negative. So that means then that this is a negative square root of 2 over 2. So now this location right here, that point, is negative square root of 2 divided by 2, and then square root of 2 divided by 2. And remembering that our points, x, y, that's the same as the cosine of theta and the sine of theta. So if I have to figure out sine and cosine, well, the sine of theta is equal to, again, the opposite over the hypotenuse. Since this is in the positive y direction, then that's just square root of 2 divided by 2. And then cosine of theta is equal to, well, cosine in this case, it goes negative direction. So negative square root of 2 over 2 over 1. So this is negative square root of 2 divided by 2. Again, knowing our reference values, all right, we know square root of 2 over 2, we have to know the 1/2, and we have to know square root of 3 over 2, and that's how we'll figure out what our triangle looks like, and then off of that triangle, figure out what sine and cosine are. All right, so let's take another example. In this case, we're going to draw negative 2 pi over 3 in standard position, and then draw the reference triangle, and then determine the sine and the cosine. All right, so in this case, then, here's our initial side, but we're now going negative. So we've got to go to negative 2 pi over 3. Well, remember, this is 0 radians, which then if I go one full revolution, that's 2 pi radians. If I'm coming this way, that would be negative pi over 2. This would be negative pi. Well, I'm in thirds. So negative pi is the equivalent of negative 3 pi over 3. So that means over here would be negative pi over 3. In here would be negative 2 pi over 3. And that leaves me with a that leaves me with a pi over 3 angle that's left. So my angle then will actually do this. All right, so here to here is 2 pi divided by 3. Now, if you're not comfortable yet with the pi over 3s and the 2 pi and the everything in radians, convert it to degrees temporarily to go ahead and draw so that you can have a better visual, and then work from there. So now if I'm drawing back to the x-axis, because again, I need to find this point here. Well, I know this angle, I'm going to have to draw an angle in there. This angle is pi over 3, just that angle in there, because now I'm dealing back with the triangle itself. So my reference triangle, again, just using it as my reference of all the values. Remember, in a 30, 60, 90 right triangle, that the shortest side is going to be 1/2, and that the longer side that is not the hypotenuse is going to be square root of 3 divided by 2. Now I got to take into account direction. So notice on the x-axis, this is a negative value. And in the y direction, this is also a negative value. So this point, again, down there is at negative 1/2 negative square root of 3 over 2. Well, the first part of the point is the cosine. The second coordinate, the second component is the sine. So therefore, sine of negative 2 pi over 3 is equal to negative square root of 3 divided by 2. The cosine of the angle, negative 2 pi divided by 3, is equal to, whoops, that's supposed to be a negative there. It just didn't draw. Negative 1/2. All right, so now let's do another example. And in this case, though, I'm being asked to draw all the way to negative pi. So like we just talked about, this is negative pi right here. And this point right here, so now I can't draw a triangle. I can't draw a reference triangle. But I do know the point. So the point is an x value at the negative 1 and a y value of 0. Well, then that means that sine of negative pi is equal to, well, negative pi, that's going to give me the position on the unit circle. Sine is the second component, so that's 0. Cosine of negative pi, and then again, remember, these go cosine theta, sine theta, so here's my cosine value of negative 1. It's actually easier to know the quadrantal angles because there's just, you know exactly that point. So it's easier to work in reverse with those. Okay, hopefully this was useful and helpful. If so, please subscribe to our Charahoe Pre-Calculus YouTube page, and have a great rest of your day.